Hi, my name is Jongjia Eun, and I would like to present you my final year project, which the title is Development of Vision System for Classifications of VD Rice. Rice is actually a cereal grain, most widely consumed staple foods for more than 1/3 of the world's populations. However, sustainability of rice productions worldwide encounters huge impact when the issues of VD rice becomes critical in recent decades. Weedy rice is also known as red rice because of its outer pericarp. This weedy rice actually has strong seed dormancies and high competitive ability, which causes yield reductions. When this harvested crop contaminated by this weedy rice, it actually can reduce the rice quality and also affects the market price. Therefore, rice grading is a necessary process. It's required to spread out the weedy rice before the rice is distributed to the market and also to the farmers. Rice grading is actually a process of determining the quality of rice grain and later categorizing them into their corresponding classes and grades. So grading is a necessary process, and normally this process depends on the visual characteristics of these rice grains, which will later decide their qualities and price in market. So there will be two decisive factors that need to be considered in determining these rice grades. So the first will be the rice attributes, and the second will be the grading method. So the problem statement will be, the existing grading method may not suitable for all the rice varieties in Malaysia. The second one will be the accuracy in classifications may vary under different conditional factors. The objective of my project is to develop a machine vision system to classify weedy rice and other cultivated rice. The following aims will be to generate the best parameter for classifying weedy rice in different varieties of rice grains. So this will be the entire methodology for my project. So from the start, it will be sample collections and preparations. So the rice kernels undergo some measurements of moisture content before proceed to image acquisitions. So after image acquisitions will be image processing and segmentations, and followed by feature extractions and also feature selections. And last will be classification and also performance analysis. So for this performance analysis, I will actually conclude from this confusion matrix. So this will be the proposed methodology. So for these rice grain samples, actually there are 3 rice varieties that used in the studies. The first will be the MMK2RC2, the second one is MR297, and the third one will be MR307. This grain samples is actually provided by a company, and the company is VC Agrodex Sedang Berhad. So this is the image acquisition system. From the image is actually a setup to capture the image of the rice grains. So this system actually consisted of a CMOS camera equipped with a CS lens mount, LED strip lights, a power unit, a personal computer, and also a black cardboard. So actually the black cardboard is used to cover up the system when the image acquisition process is carried on, so that it won't affect by the environmental noises. So it won't affect the process when I capturing the images. So for this system, before I capturing the image, the exposure and white balance for the camera was adjusted, and the rice samples were actually placed manually and is placed separately so that to prevent touching kernels. And the imaging setup is actually covered by the black cardboard. So for the image processing part, it will start from the conversions to grayscale image, and later removing isolated small aggregates, which is actually also known as noise removal. After that will be followed by smoothing and filling holes, and followed by thresholding and also labeling. So after all this process, we can actually extract the features. So for feature extractions, a total of 9 parameters is actually extracted, and including 5 regarding to morphological features, which is areal parameter, major axis length, minor axis length, and also aspect ratio. And another 4 is based on color features, which is mean intensity and also RGB. Yeah, after I have extracted all these features, I need to select the most significant features. So I use principal component analysis and also one-way ANOVA to select the really best parameters for the following classifications process. And after all this processings, and that's come out this result, and as you can see, there are three images there, and actually in this classifications I have used logics algorithms. Yeah, for this logic algorithm, actually I have used AND and OR operators. So as shown in the figure, when AND operator is used, actually there's four kernels that are misclassified as normal rise. So when OR is used, we can see that actually more VD rise is, which is all the VD rise is actually correctly identified. Yeah, so based on the confusion matrix below, we can actually show that when using all operators in the logics algorithms, actually all operators have shown a high accuracy as it can detect most of the VD rise. So among the 72 rise grain, 53 of them were correctly identified, and the rest were misidentified, showing an overall accuracy of 73.61% for both operators. Yeah, so however, I have preferred that the classifications carried out should, on each variety, show a higher accuracy rather than using only a threshold value for all the varieties. Yeah, so as the table show that when we classified the rice strains based on rice variety, is actually shown a more higher accuracy compared to when we consider all the rice variety as one. Yeah, and between AND and OR operators, and OR operators is actually showing a higher accuracy for almost all the rice variety. So for conclusions, we can say that each variety of rice grain should has their own threshold value in separating out the VD rice, since different varieties have different characteristics. So it is better to classify them based on their variety. Yeah. So in this research, actually there's some limitations, which is there's limited numbers of rice kernels. So in futures, there must more samples and rice varieties should be collected in order to improve the accuracy. So for the image acquisitions part, it is instead in a static motions, it can be using a conveyor. So it will have some slight movement, so that more by using a conveyor, so more conditional factors can be considered when this grading process is carried out. Yeah. So the authenticity identifications of VD rice among the rice variety is the most important problems for now associated with rice industry. So the ideas and plans presented in this study can be implemented for achieving further progress in the field and also in industry. Yeah. So okay, so this will be the end of my presentations. Thank you, everyone.